All right, guys. Natalie, Jaden, James, Adwell, Emma, Vanderman, Paul. Oh, they have a tennis thing. Brockman, brothers, Colton brothers, Callahan, Ashlyn, Dow. Oh, they have golf thing. Christina, Chaz, Gibbons, Hawes, Casey Hawes, Lindsay, Justice, Larkin, Miguel, Meacham, Colby. Pace is here. Foss, Andrew, Aiden Rath. Okay. Leslie's here. Melissa here. Raw, Martha, Hurricane, Cameron, Tucker is on Zoom. Logan Wade, Jared, Jocelyn here. What is your name? Casey. All right. We're going to continue with chapter 7 today. Let me save that. Last time we talked about special cases of no dividend growth or constant dividend growth. Now we will think about two-stage here. We're going to assume that we know what the dividends are going to be for a small number of years. Dividends are forecasted. Then we will assume a constant dividend growth after that. We'll develop a template for this, but for now, let's do an example. Suppose the company is expected to pay $1, $2, $3, and $4 for the next 4 years. After that, they are expected to grow the dividends at 5% a year, assume a discount rate of 12%. What is the value of the company or a share of company? And what are your names? You just came in. Now we're going to approach this in kind of two ways. Assume that cash flow from the company is divided into two parts. I'm going to call one uh, early company, and if you own the shares of early company, the only thing you get is you get the dividends for the first 4 years and nothing after that. The second one is the late company. If you own the shares of late company, you will get nothing for the first 4 years. And get all the dividends after that. Now, calculating a value for the early company is easy because you know exactly what you're going to get and exactly for how long. Calculate present value of the dividends for the first 4 years and add them up. I'm going to do it here first, and when we build the templates, it'll be easier to do. Well, year one, you're going to get exactly $1 and divide that by 1 plus 12%. So that $1 you're going to get 1 year from now is worth 87 cents now. In fact, let me call this PV1, 89 cents. PV2, you will get $2, but you're going to discount that at 1 plus 12% raised to the power 2. You're discounting twice. So that's equal to 159, $3, 1 plus 12% raised to the power 3. And the fourth year, you're going to get 1 plus 12% raised to the power 4. Hence, value early. I don't usually recommend that you round these things up, but this is illustrative. 89, 159, 214, 254. So if you own the shares of the early company, uh, that those shares are equal to 716. In fact, certain companies do sub shares. You know, you get the certain percentage of earnings as dividends, and the rest, whatever there is left. Now, let's think about the valuation of the late company. It does look like that this is a company with constant dividend growth, but that growth does not start until 4 years from now. So we're going to do a little bit of time traveling. Value of late now. For the first 4 years, I get nothing. And at the end of fourth year, I still own the stock, right? If we travel to the future and according to laws of physics, that is possible. If you travel around the Earth at 0.999999% of speed of light, and if you do that for about 4 years on Earth, there would have been only maybe 1 hour passed in your ship. You're going to age only for 1 hour. That's called general special relativity for you. Same thing happens if you orbit a black hole. Time, dilates quite a bit. So traveling to future is indeed possible as long as you have the technology to travel at that speed. Right now we don't. I mean, the best thing that we can ever hope, maybe 5% of speed of light, and that's only after a lot of solar sailing. Those solar waves, if you have sails, they actually keep increasing your speed. Even big stuff. Have you guys heard about supernova? These are suns or stars that explode, and there is a certain physics to it. If a star is bigger than 2.1 times mass of sun, eventually it explodes as a supernova. The physics is somewhat what you want to call complicated, but when that does, it sends all that stuff to space at very high speed. There is currently the last supernova that was seen clearly was in year 1054. It was visible during the day. A star being visible during the day is something. In fact, for a while, it was much, much brighter than Venus. The remnants of that is actually this little picture. That is what's left of that supernova. It is still traveling at 0.5% speed of light, and it's about, I think, close to 100 light years wide. So we travel to the future. What was your name?